So our next speaker is Mike Fleeman. For those of us who live up in the Phoenix area, most of us have had the pleasure and honor of visiting his gallery on more and more occasions. He's a collector of minerals. He is a collector of human artifacts. And we're not just talking a pot, from some Indian burial in Arizona. We're talking about things that are thousands and 5,000 and 10,000 years old. He really goes in for the really ancient stuff. But his real claim to fame is he's got the finest private collection of petrified wood that I know of. Now, I'm sure that there's some people in the northwest part of this country that they could lay claim to that, but at least for Arizona, it's a hell of a collection. And just a few months ago, I think it was Don Bushell, wasn't it? That showed up and put a black light on one of the slabs of petrified wood, and lo and behold, they started fluorescing. So when I found out about this, I invited Mike to come and talk to us about his fluorescent petrified wood collection. So now it's a dual collection. So Mike, it's all yours. Thank you.
Thanks everybody, and good night. No. No. As Les said, Chris came up to the showroom, and I have a pretty big collection of petrified wood displayed, but really never took the opportunity to put a black light up to it, a UV light. And lo and behold, we discovered some remarkable fluorescence within the petrified wood itself. Now, there hasn't been a tremendous amount of study about fluorescence and petrified wood, so I'm kind of limited to the information I'll present, so just kind of bear with me on that. But of course, people that know me that when I've done lectures, generally I bring specimens and I kind of do a show and tell thing. So this kind of lighthearted thing, I always think I look like the guy at the top, but it's usually more like the guy on the bottom when I do presentations. So.
Mike, without the microphone, would you speak up just a little bit?
Sure, absolutely. Now, fluorescence in petrified wood is due greatly to uranium, and there's a lot of concentration in the Four Corners area of the United States, up toward Montana and Colorado. A lot of old uranium mines in those locations. We're going to kind of concentrate just with a little bit of basics on the uranium in the Arizona and New Mexico area. But I have specimens that we checked for fluorescence that are actually from all over the world. So I'm going to present different locations, but a little bit of focus just on Arizona. Breccia pipes, where you have the collapsed sandstone formations that are very old, and you end up getting the uranium that comes up from the groundwater up into these breccia pipes. But you also have roll front deposits. And up in the Chinle Formation, you get these roll front deposits where uranium is deposited horizontally in a lot of these sandstone layers, specifically the Chinle Formation where a lot of petrified wood is found. So with the roll fronts, there's oxidation and the uranium deposition. The petrified wood, basically a couple things have to happen for petrification of wood or any fossil formation. You need to remove oxygen and bacteria fairly quickly. So a lot of the Pacific Northwest and the Southwest, a lot of old volcanic activity that goes back many hundreds of millions of years. You get these volcanic explosions, ash will blow down a forest, kind of like some of you remember Mount St. Helens, where it just obliterated that forest in front of Mount St. Helens. Bury it very quickly with volcanic ash, and then you get, the proper environment for fossilization or petrification to occur in petrified wood. Of course, another byproduct of uranium is yellow cake, which is used for reactors and stuff like that. Another thing that I recently learned with calcite in petrified wood, you get your typical calcite that will really fluoresce beautiful, bright pinks, oranges, kind of peach colors, is actually due to manganese within the actual calcite. So I don't know about you guys, but I have a couple manganese calcite specimens that are really brightly fluorescent orange. Oops. Oh, there we go. So here's a piece of what's called Araucaria arizonicum from the petrified forest area. And you can see a lot of the different colors that form petrified wood are due to the minerals and the elements within the ground where they petrify. Arizona wood is commonly known as rainbow wood. A lot of people call it that for obvious reasons, the beautiful array of colors. There it is under UV fluorescence. You can see there's a couple different uranium minerals that actually activate these different colors. There's one called zippyite, and that's the one that's responsible for that bright yellow color in the center. And you can see there's a little bit of calcite in there as well, the red in the very center. The exterior part is a combination uraninite, which some of you know as the old pitch blende. There's a Tayuya moonite, which is difficult to pronounce or spell. There's another one called coffinite, and those are different uranium-bearing minerals that produce these bright greens as well. This is a piece of petrified wood from northern Nevada, a place called Hubbard Basin. Another favorite amongst petrified wood collectors. You can see a real nice tree ring formation. This is actually a spruce tree that was petrified. The northern Nevada stuff tends to be very brightly green fluorescent, so it has a lot of the uranium in it. This is an interesting piece. This is actually moving around the world. This is from Zimbabwe, Africa, and this is a species of an ancient tree fern called a rexaxylon, no longer in existence. This happens to be the only full round of rexaxylon in existence where the secondary xylem or water channels are pink. Those pink spots are the water channels in the fern. But this is the only known full slice of that in existence. Fluoresces bright gold yellow. By the way, that specimen's about 5 inches, not real big. The tree ferns generally aren't as large as some of the Arizona material. This is an agate limb cast. Now, you probably all know, but I'll explain it to maybe some of you that don't. There's petrified wood and then there's limb cast. Similar process, but a limb cast, it gets buried by hot ash, so it burns the log out, so it leaves a hollow cavity. Within the hollow cavity, fluids fill that cavity, rich in silica and other minerals, precipitate in the cavity, and they form basically like an agate. You've all seen plenty of agates. So this is a limb cast from China, a slice of a limb cast. Again, very, very bright fluorescence. Now, again, I mentioned earlier that there hasn't really been a whole lot of research or study to fluorescence in petrified wood. So I'm going to be perfectly honest, I don't know what's causing some of the fluorescence in these specimens. Hoping to do some of that research in the future, but some of these I just don't know what's making them fluoresce the color they fluoresce. Anna?
Is this long or short wave?
I believe most of these were, Chris, yeah, some of these were long wave, yeah. By the way, I do want to mention, Chris was instrumental in helping me photograph all this. He did all the fluorescent photographs. Bill Yedowitz, actually, at the end, there's a couple that he helped do as well. This is a really beautiful log from Brazil, and it is actually purple without fluorescence. Really neat piece. It's a species of Araucaria, I believe. I don't remember the exact species, but it's a conifer. But this one really fluoresces just insane. We couldn't believe it when we put the light on this one. So again, you've got a mixture of different minerals going on that are forming the fluorescence, but a lot of different uranium deposits.
Is it short wave or long wave?
I think this one might be, did we do both on this one?
Yeah,
I think we did both.
triple. So you got
Yeah, I think there's short, medium, and long wave on this. But this one, and this one I think came out as good as it looks in person. Some of these the photos really don't do these pieces justice because they really glow bright. I put this one in here even though it doesn't fluoresce real bright, I'll show you, but it's an important piece. This is a piece of Ginkgo beckii, related to the modern day Ginkgo biloba tree. This is off the holotype specimen from the museum in Washington. Ginkgo is probably in the top 5 most difficult petrified woods to acquire. I know most of the big collectors around the world that collect pet wood, and very few of them have any ginkgo. Again, this one, the center of this, that band, glows a deep purple color. Now this is St. John's area, northeastern Arizona. Again, another Araucaria specimen with a little bit of rot in the center, so you got a little bit of the chalcedony crystals forming in the center. Now this particular one, and I didn't post a photo, but there's another species from northern Arizona called Schilderia. Another very rare species, makes up maybe 1% of the entire petrified forest. These specimens, for whatever reason, glow bright orange, but they're primarily silica, but there's got to be something in there making them glow bright orange. So I'm thinking maybe there's some manganese possibly in these as well. Now this is another limb cast from Wyoming. Again, not petrified wood. As you can see, there's no structure remaining. It's just all replacement with agate. Now this one is another one that baffles me because you can see it's clearly quartz with some agate banding. But under fluorescence, it glows bright white, but there's a peach to pink hue behind the quartz, so I'm thinking there must be some calcite maybe or something else in there. But this one, for whatever reason, the quartz glows bright white. Now I know we have, some of you have probably seen the chalcedony cups from New Mexico that I have a few that, you know, they glow bright green, and there's some other places in Arizona as well. We have some really beautiful fluorescent minerals. This is a piece from Burma, country of Burma actually. An unknown hardwood, tropical hardwood, real kind of unique mineralization in this piece. It also glows bright white and blue. So again, some really unusual fluorescence in some of these pieces. Most of you are familiar with the fossil cones. These are fossil cones from Argentina. Became real popular with collectors for a while. These are actually, they're not illegal to own if you own them, but exportation from Argentina and importation now to the United States has been completely banned. So if you were fortunate enough to get some of these, you're lucky, because the only way to get them now is if they pop up out of old collections. I'm fortunate to have a substantial amount of these. And again, never would have thought that these were fluorescent. We put a light on these and they're bright yellow. And these cones date back to about 145 million years old. I do want to mention a little bit of astronomy thrown in here with this today. I just learned this, but I thought this was really fascinating. Arizona wood from the Holbrook region is about 225 million years old. I just learned that we're in basically the same spot in the galaxy that we were when that wood was being formed. It takes approximately 225 million years for us to circle the Milky Way galaxy once. So I found that remarkable that we're in the same spot as we were 225 million years ago when Arizona was nearer the equator and these huge trees were becoming petrified. To me, that was just kind of a cool little fact. Nice limb cast again from Farson, Wyoming. Some of you may have heard of Blue Forest. That's a real popular collecting area for petrified wood. Farson is north of there. You can see the details in this piece. If you look at the top, you can tell that it's all agate. There's no structure remaining. However, once in a while you get lucky when there's preservation. You can see the imprint of what would have been the bark of the tree. There's no bark, obviously, but you can see the imprint. That's another thing I want to mention about petrified wood. I've heard a lot of people lecture about it. I know a lot of collectors, particularly Arizona wood. They always think that rough rind around the exterior is fossil bark. I'm here to tell you it's not. Fossil bark is remarkably rare. From Arizona, it is almost off the chart rare. I know of maybe 2 pieces ever found, and they're in the museum at the Petrified Forest. The only places that are known for fossil bark, Blue Forest is one of them. There's a couple other locations. But actual fossil bark is remarkably rare. So there again, you see fluorescence, the middle of this piece, and some of the exterior bright blue, but there's this unusual band of bright kind of yellow gold running around it and down the side. This is an interesting one from the Henry Mountains in Utah, again, a place that's loaded with uranium. This happens to be a piece that was decayed before it was buried and petrified. So it has Polyporites wardii fungus. That was a type of tree fungus back then that attacked the log. So all those circles that you can see in there literally are fungal pockets. There's very little remaining structure to this tree left. So the bulk of it is actually all fungal pockets. So it was heavily rotten before it petrified. This one happens to really fluoresce wildly. You can see clearly the fungal pockets are fluorescing one way, and why they absorbed one mineral to fluoresce one way, and then you see the red is calcite and some other stuff. Again, I don't know why the fungus picked up some of the minerals versus something else. But very unusual fluorescence. And I can tell you this one in person is even way better than the photo. It just screams bright colors. This is another really cool piece from a place that is, amongst petrified wood collectors, highly coveted. It's called Zuni Wash, which is between Arizona and New Mexico, northeastern Arizona and northwestern New Mexico. This is an old school piece that I got from an old collector, very fortunate, because it's very difficult to get this stuff. Beautiful material, and again, kind of glows like the first Arizona piece. You get the gold coloring in the middle from the zippyite, and then the uraninite and the other one around the outside causing the bright green colors. Some of these slabs are really big, so I apologize for the glare. You can see the purple square in the middle and on the far right. Those are just reflections from the fluorescent light. So if any of those pictures aren't to your satisfaction, blame Chris. It does. That's a good question. I have a huge piece from China. I didn't post it because I'll be honest, I was kind of embarrassed. I knew it had a repair. When we put the black light on and took a photo, man, it was like, oh, it was really ugly because he had these huge fractures that they repaired. So yes, that's a good thing for minerals as well. When you put ultraviolet light on some of this stuff, it really shows the imperfections really bad. This is a limb cast from one of my favorite locations. Some of you may have heard it. It's called Tusher Canyon, also in Utah. It's near the Yellow Cat Mining District, which is a really famous mining district for a lot of things. But Tusher limb casts are some of the most sought after limb casts in the world because they're stunning in color just the way they are. I've got a very large collection of these that I was fortunate enough to get it from a gentleman that I knew in Texas who sadly passed away. He had probably one of the finest limb cast collections from Tusher in the world. Now here you can see, if you notice the exterior rind, it glows kind of an eerie dark green, again from uranium, and then the center is, pure calcite, so nice, beautiful, bright orange. Now, I'm here to tell you, that's Chris's hand. I don't know what's going on with Chris's hand in the background, but use caution because that's a little scary. Yeah. This is a vertical slice through a cycad. If you don't know cycads, they are a very unusual plant group. Cycads are their own group. They don't fall into any other category. They're not trees. They're not a grass. They're not really a flower. They're kind of an odd grouping. Now, anybody here have sago palms in their yard? Guys heard of a sago palm before? Sago palm is in fact a cycad. It is not a palm. And palm trees also are not trees. They are a grass. They are not trees at all. We call them palm trees because of the way they look. But palms are actually a grass. But this is a vertical slice through a cycad from Argentina. And this is one of my favorites. That's why I put it last. This one is stunning in person. Just bright green and bright yellow. The yellow really didn't come out as well as it does in person, I think, because the green was so bright. But really a really cool contrast in this piece. Again, I just wanted to list my references. I didn't end up, like I said, listing Bill Yedowitz in here. Bill, if you're here, don't beat me up, I'm sorry. I should have listed you because a couple of those photos were from Bill, and I, of course, waited last minute to put everything together as well. So.